In this video, we will learn about derivative. Derivative measures steepness of the graph of a function at some particular point. It's a slope. That means it's a ratio of change of value of function to change in independent variable. Suppose a function is given like this, y is equal to fx. So derivative is how much does y or fx changes given a specific change in x. So the slope is defined like this, is a change in y divided by change in x. So a function, let's say this is a y and this is an x, and it's given like this. So slope at particular between 2 points a and b is, we can measure as this is a change in y and this is change in x. So slope is just a simple difference between change in y and change in x. But what if we want to find the slope at one particular point? Because here we don't have 2 points. How can we do that? How can we find the slope at this particular point? So to do that, we consider a very small change, that is h. Assume y fx is a differential function at point x0. Then derivative of the function at this point is given by this equation. So what is mean by h? H is a very small change which tends to 0 or shrinks to 0. So x changes from x to x plus h, very small change, and y changes from y, that means fx, that changes from fx to fx plus h. So change in y is defined as fx plus h minus fx, and change in x is defined as x plus h minus x. So after this equation remains. So the above one is change in y and the below one is change in x. And this limit h tends to 0, it's just shrinking to 0. So like if we given this function, so very small change like this, that denotes dy or this denotes dx. So in another form, it is written like this. So it's a simplistic form of this. So the process of finding the derivative is known as differentiation. To find the derivative, what we can do is first we fill the slope equation and then we simplify the slope equation and shrink the dx to 0. Let's consider an example of this. So consider an example of fx is equal to x square. So f x plus dx as per our slope equation is denoted by x plus dx square. Just putting the instead of x plus dx in the equation. Now our slope is defined as change in y divided by change in x. So slope is simply as x plus dx to whole square minus x square divided by change in axis, which is simply the dx. So simplifying this equation, So this x square nullify by this. We remains with 2x dx plus dx square divided by dx. So dividing dx in both, that is 2x plus dx. Now this dx tends to 0, so we can just simply put a 0 and keep only the 2x. So that is 2x. That means the differentiation of this above function with respect to x is 2x for this one. Yep. So now let's understand some important rule which is used to understand the concept of derivative in machine learning. First is the power rule. So power rule says if we have functions like this, fx is equal to xn, so the differentiation of that function is written like this: dfx by dx is equal to n x to power n minus 1. Suppose, for example, a function is given like this, 4x5. So the differentiation is 4 into 5 into x to power 5 minus 1, which is 20 x4. It's simple. So whatever the power we have here, we just reduce it by 1 and we put it as a product in the front. So very simple. Like if we have fx is equal to 3x square, so dfx by dx is defined as 3 multiplied by 2, that is 6x. Let's understand another rule, which is chain rule. So it is used to find the derivative of a composite function. So let's say we want to find out the derivative of y of x. So it can be defined as derivative of y respect to z and derivative of z respect to x. Suppose the function is given like this: y is equal to 3z and z is given like this, 9x square plus 2. Yeah. So first what we can do is to calculate dy by dx, we calculate dy by dz first. So that is just a 3. Like if we do here according to the previous power rule, this 1 comes in the front and z goes, so it's a 3. And dz by dx, so putting this dz by dx, we get 18x plus 0, that is 18x. So here we get 18x. So dy by dx is equal to 3 multiplied by 18, that is 54x. That's a chain rule. Another important concept is partial derivative. So if we have a function of 2 or more variable, then to find partial derivative of a function with respect to one variable, treat other variable as a constant. For example, if we have a function like this, fxy is equal to x square y, and you want to find the derivative function with respect to x. So we can do this by putting y as a constant. So treat y as a constant and find the derivative of x square. So that is 2x is equal to 2x. Now the same, if you want to find out the derivative with respect to y, what we do, putting x square as constant and derivative of y, that is 1. So that is x square. So this is all about derivative, which is used for the machine learning for our immediate need. Stay tuned for more updates.